Topic 3, risk and risk management. Now, gross margins are useful in farm planning, but they're actually based on expected values. Simulation models are useful for within-season tactical decision making relating to nitrogen applications and spraying decisions. And one of the reasons that they're useful is that they actually give the probability distributions around gross margins and returns. Now, why is this important to a decision maker? Well, a farmer tends to show what's called risk aversion. So that means that they will avoid decisions that, although they might have quite a high expected value relative to other decisions, also have a very high risk. So farmers, by and large, tend to want to avoid having too much risk. So you're already familiar with the use of risk profit because with yield profit, because I believe you're using that in your current assignment. So what yield profit gives you is a distribution of yield potentials. So here the yield potential is given with current nitrogen and with unlimited nitrogen, and this gives the figure for different levels of rainfall. So how do we interpret this? Well, stochastic dominance is quite a useful way of comparing distributions of returns, or in this case net revenue. So here we're just taking the price of nitrogen off. So with 0 kilograms of nitrogen, then this is the cumulative distribution of returns, and with 25 kilograms of nitrogen per hectare, then this is the distribution of returns. And because this distribution here is everywhere to the right of this distribution, then we say that this distribution with 25 kilograms of nitrogen stochastically dominates this distribution. But when we have, let me say we have two distributions that look like this. So choice A is potentially less risky, and choice B is more risky. And both of these distributions have the same expected value. Then a farmer might prefer choice A over choice B, just because choice A is less risky. So there are fewer extreme values. So there's fewer very, very low values of the net revenue, and fewer very, very high values of the net revenue. So we can compare distributions of total gross margins or net revenues using stochastic dominance. And in this case, there's a clear distinction. Here, it depends upon the decision maker's attitude to risk. Risk management, crop portfolios. So one way of thinking about the choices that a farmer makes is that he's allocating his budget of land or resources to different crops, and he's doing that in a way that manages the risk. So if a farmer only produces wheat or only produces barley, then the likelihood is they're going to have very high risk, because they're basically putting all their eggs in one basket. Now, one of the ways of measuring risk is, let's say we've got two crops. So crop 1 has a variance of sigma squared 1. Crop 2 has a variance of sigma squared 2. But these variances are actually the same. So there's equal variance of the from the two crops. Well, let's say that the crops have also got the same expected gross margin, so you can't really distinguish between them. And if we say that the total variance of these two crops is given as follows. So A is the area planted to crop 1, A2 is the area planted to crop 2, and to get the total variance, then you weight the variance by A1 squared and A2 squared, so that's the variance for the crops, and then you have this covariance term, which can be represented in this way. So it's the standard deviation of crop 1, standard deviation of crop 2, area 1 times area 2, and you've got this correlation coefficient here. Now, the interesting result from this is that the risk minimizing portfolio, that is the variance minimizing portfolio, is always where the area of crop 1 is equal to the area of crop 2, and if there's 100 hectares to plant, it's equal to 50. Or if you're saying what is it in terms of proportions, then the variance is always minimized where 50% of the resources are used to produce crop 1, and 50% of the land is used to produce crop 1, and 50% to produce crop 2. So and if we represent it using confidence intervals, then it looks like this. So that if we have 50 hectares of both of the two crops, then the confidence interval is narrowest at that point. If you planted all of crop 1, then you'd have a very wide confidence interval. If you planted all of crop 2, you'd also have a very wide confidence interval. So this shows that you get risk management almost automatically by diversifying the enterprises that you grow on a farm, just because of this simple rule about the total variance and the effect of covariance. This rule would not hold only if the correlation coefficient is equal to 0. If that was the case, then it wouldn't matter, what area of the two crops you grew. If it's what you tend to find with most crops, so something like wheat and barley, is actually the correlation coefficient is pretty well always positive. It's fairly unlikely that you'd have a negative correlation coefficient. So the yield, because it largely relates in Western Australia, for instance, to rainfall and environmental conditions, then you tend to get the gross margin of crops being positively correlated. So just to summarise the three topics, I'd just like to emphasise the importance of economic principles to farm management. The reason for planting crops is basically to maximise profit. Gross margins are a good first step in that they introduce some economic principles, and they're giving a return to the fixed resources. But then things get a bit more complicated in topic 3 with the importance of risk management. And optimisation and simulation are the way forward for agribusiness management, especially in Australia, due to the very high risk levels that farmers face with rain-fed agriculture. Thank you very much for listening to me.